Okay, so everyone is talking about AI agents, but let's get one thing straight. An agent without a robust retrieval system is really just a fast-talking hallucination engine. The real magic, the real power, isn't just the LLM, it's the data you can ground it in. Today we're diving deep into the evolution of that retrieval engine, RAG, all the way from the simple pipelines to the truly intelligent systems you're going to need for 2026.
So, first things first, let's just clear the air. You might be hearing some buzz that RAG is old news. Look, that could not be more wrong. RAG isn't dead, it's just evolved. It is the absolute foundation for everything that comes next, from advanced search all the way up to those full-blown agentic systems.
I mean, think about it this way. Without a strong retrieval system to ground it in actual facts, an AI agent is basically just guessing. RAG is its tether to reality. It's what turns it from a confident-sounding but totally unreliable black box into a tool you can actually trust.
To get this right, we're going to break down the 7 essential RAG design patterns that you absolutely need to know. This is the stuff that separates a simple weekend project from a production-grade, enterprise-ready AI system. So yeah, let's get into it.
All right, we're going to start our journey at level 1 with the foundational patterns. You know, every great system is built on a solid understanding of the basics, and RAG is absolutely no exception. So the very first pattern is what we call naive RAG. This is literally the hello world of retrieval-augmented generation. You take a document, you embed it, you stick it in a vector database, and then the LLM pulls context from that database. You know what? It's simple, it's fast, and it's fantastic for prototypes or maybe some small internal tools.
But, and this is a big but, in production, naive RAG really starts to show its cracks. It's great for getting off the ground, sure, but it often retrieves a bunch of irrelevant context, which leads to lower accuracy and, you guessed it, hallucinations. To build a truly robust system, we need to improve the reasoning and cut down on all that noise. And that is our first level up.
And our first level up is pattern 2, retrieve and re-rank. The best way to think about this is like adding a quality controller to your pipeline. You still retrieve an initial set of documents, say 50 of them, but then a special re-ranker model, usually a cross-encoder, meticulously goes back and re-evaluates them. It looks at the query and each document together to find the actual best context for the LLM.
And this diagram here shows just how simple, but man, how powerful this one addition is. That little extra re-ranker step acts as a crucial filter. Yeah, it might add a tiny bit of latency, but it is one of the single most effective ways to kill hallucinations at the source and just drastically boost the quality of your output.
Okay, so we've improved our quality. Nice. Now let's expand the knowledge our system can actually access. Because modern AI needs to understand the world in more ways than just text similarity. It's time to move beyond simple vectors.
Which brings us right to pattern 3, multimodal RAG. Let's be real. The world isn't just text, so our AI systems can't be either. This pattern allows your RAG system to see images and hear audio by processing everything together in a shared latent space. This is absolutely critical for applications like medical AI that's analyzing X-rays or for visual Q&A systems.
And this leads us to a huge leap in reasoning ability, pattern number 4, graph RAG. Now, while vector search is great for finding things that are semantically similar, knowledge graphs are designed to find things that are contextually related. We're moving way beyond simple keyword matching to actually understanding the complex web of connections inside the data.
And for anyone building for the enterprise, this is such a crucial point. Vector search is fantastic for unstructured text, but it's just not enough when you need absolute precision. For things like financial data or product inventories, you need the hard facts that live in structured data. And that is exactly where the next pattern comes in.
And that leads us directly to pattern 5, hybrid RAG. This is, without a doubt, the gold standard for enterprise knowledge systems. It combines the semantic power, the what, of vector search with the structured precision, the why and how, of a graph or relational database. You really do get the best of both worlds.
So here's how it works in practice. The system can actually query 2 different paths at the same time. On one path, you have a vector search pulling in broadly relevant documents based on semantic meaning. On the other path, you have a really precise graph query pulling in hard facts and relationships. By feeding both of those to the LLM, you get a much richer, way more accurate context to generate a response.
And now, for the final and I think most exciting phase of our journey, the agentic leap. This is where the system stops being just a passive pipeline and actually starts to think, to plan, and to act for itself.
So, welcome to pattern 6, Agentic RAG, specifically the router pattern.
Now, instead of a fixed, linear workflow, you have an LLM agent that sits right at the front, and it acts like a traffic cop. It analyzes the user's query and then intelligently decides what the best tool for the job is. Does this need a web search, an API call, or maybe a look inside our vector database? The agent makes that call dynamically, on the fly.
The agent is literally the central hub. It's not just retrieving anymore, it's reasoning about how to retrieve. So if a user just says, hello, it can decide not to query any tool at all. But if they ask about Q3 earnings, it knows to hit the SQL database. This is true intelligence in action.
And here, let's just take a quick peek under the hood. This simplified Python snippet shows the core logic. You can build a router that uses the LLM itself to classify the user's intent, or you can even use simpler keyword-based rules. If it sees a query about earnings, it routes to an SQL tool, otherwise it just defaults to a general vector search. It's a really simple concept, but it's the absolute foundation of dynamic tool use.
And finally, we've reached the pinnacle, pattern 7. Multi-agent RAG. Look, if a single agent is like a smart worker, this is like a whole team of expert specialists. You might have one agent that's an expert researcher, another one that critiques the initial findings for accuracy, and then a third that synthesizes everything into a polished final response. This is how you build self-correcting, truly autonomous systems.
So, we've gone from a super simple, naive pipeline all the way to a collaborative team of AI agents. Let's put this all together now and create our blueprint for 2026.
So here it is. Here's your blueprint. And notice the progression, right? We start by improving the quality with re-ranking. Then we expand the knowledge with different data types. And finally, we add reasoning with agents. This isn't just some random list of options. It's a maturity model for building increasingly intelligent systems.
And that, right there, is the ultimate takeaway. The reality for any serious production system in 2026 is that the retrieve step in RAG is no longer just about fetching documents. It's about reasoning, planning, and dynamic tool use. We're moving from simple information retrieval to complex information reasoning.
And that leaves us with one last question for you. Looking at all these patterns, which one are you currently building or maybe planning to build? Are you starting with a really solid hybrid model, or are you ready to take that leap into a full agentic system? Let me know what you think.